All right, today's quiz day to kind of see where we're at for chapter 3. And basically, um, this depends on where we are in class. So maybe this isn't true about the packet part number 3 here, but for sure, we're going to review in this video and then you'll take a quiz on Schoology. All right, so it's just reviewing stuff from chapter 3 and we're solving systems, right? So remember a system of equations. So like one equation would be x plus y has to be 10 or something like that. That'd be one equation. And then a system has a second equation like x minus y. We want that to be 2. And then there's different methods for solving. The 3 methods are graphing, combinations or elimination, and then the final one is called substitution. All right, so this one would be set up real well for the combinations, where you could just add the 2 together. So you get x plus x is 2x, the y's cancel out, and you get 12. Divide by 2, and boom, you got x6. And remember, your solutions to the system are an xy pair that works for both. So if x is 6 here, then y must be 4, right? And that should work in both equations. So 6 plus 4 is 10, and then 6 minus 4 is 2. So this would be the right xy pair that works for both of the equations. All right, so as always in these videos, I strongly encourage you to try it, right, first, before watching my solution. And for the most part, our big goal in here is to be able to pick the method, right, because one of the reasons we have 3 methods is some are better for certain situations. So pick a method here and give this one a shot. All right, so this one's going to work well to use the substitution method. Okay, and the reason is we almost have y alone. So if we go to the equation on the left, if we divide it all by 2, we get y equals 4x minus 20. Okay, and then we're kind of on our way, right? Because this quantity can now be substituted in for y into the equation over here. So we have 3x plus 5, and then replace y with 4x minus 20 equals 38. All right, so then we have 3x, distribute the 5 here. All right, so this equation now has only x in it, so we should be able to get x alone. All right, and then combine like terms, 23x minus 100. Add 100 to both sides. Okay, and then divide by 23, and we'll get x to be 6. Okay, and then to finish it, we got to find y, so I'm going to plug it in back over here. So y, or x is 6, so we have 2y. Actually, I could probably use this one down here. That'd be even better. Let's just use this red one here. So we can do y equals 4 times 6 minus 20. Realistically, you can use any of the equations, but that one should work pretty good. 24 minus 20, because we have y alone already, so we just got to do some basic math, and we get y equals 4. So our solution x6, y equals 4. All right, next one. Give it a shot. Pause the video, give it a shot. All right, when you have them both in standard form, where x and y are on the same side, it's going to work really well to do the combinations method, right? That's where you add them together and get them to cancel out. So the trick on this one is to realize that this is a 1x, and so I can get it to match with this 3 pretty easily. In fact, I want it to be negative 3. So with using that 1x, you just take it times negative 3, and then write it underneath here. So I'll have negative 3x, and then distribute it to all the parts, 15y, and then negative 3 times negative 24 would be positive 72. And now we can add them together, and it'll come out nice and neat, because those will cancel out, and we'll get 13y. Okay, and on this side, we'll get 65. Negative 7 plus 72. Divide both sides by 13, and we'll get 5 for y. All right, now we got to find x. You can use any equation. Maybe let's plug it into the one over here. So x minus 5 times 5 has to be negative 24. And so multiply 5 times 5, 25. Add 25, and you get 1. So our solution is y5 and x1. All right, next up, any method again. Pause the video and give it a shot. All right, so the method that's going to work best here is substitution because we already have y alone. So we can just throw it into the other equation over here. So 4x plus 2y. And so I'm going to take out y. Like a bad basketball player hasn't been playing very well. So I'm going to take it out and replace it with something else, which is 5 minus 2x. And now the equation has only x in it, so we can solve that. So just clean up the left-hand side, distribute. Okay, and then we're going to get a weird thing that happens here. 4x and minus 4x cancel to 0, so we get 10 equals 10, which is what the crap. I can't figure it out. X and y are both gone, so I'm not sure. We just got to know that this is one of the special cases, and this is always true. The sides are always equal, right? So when that happens, that is the infinite solutions case. Okay, so this has infinite solutions. If you get the two sides not to be balanced, like 0 equals 2 or negative 1 equals 4, then it's no solution. Right? Those are examples of no solution. This one here would be an example of infinite solutions. All right. Pause the video, give it a shot. All right, so combinations again, because they're both in standard form. So I would take this one, and I could get, this is again 1y, which is often useful in combinations because you can multiply by whatever you need to get the matching coefficient over here. And so I'm going to do 2, and that will work perfect because we'll have negative 2i and positive 2y. I'm going to rewrite it underneath, multiply all of it by 2. Okay, and then we add them together, and so we get 0 plus 0 equals 0. And again, that's our special case. So it looks like this one's another infinite solutions. And you know, in some ways you might have been able to realize that these are really the same equation. If we had taken this first one times negative 2, then you'd see that they're the exact same equation, and that's another sign that it's infinite solutions. All right, last one for you. This is a story problem. Pause the video, give it a shot. All that's different here is you have to write the system before solving. Okay, so the two variables are the cost for a math book and the cost for the English book. All right, so we know when Ethan is in the store, he buys 3 math books plus 4 English books, and that is $115. And then Ryan comes in and he wants to do a little bit more math, so he gets 5 math and 2 English. He gets charged $145. Okay, so now we want to find the cost for each book. So that's our system. And then again, this one I generally use the combinations method because they're both in standard form, right? So this is a tricky one where we don't have like a 1m or 1e, so we're gonna have to multiply. Actually, no, we're okay. If we take this one times negative 2, then the e's would cancel out. So actually, it's not too bad. So negative 10m minus 4e equals negative 290. All right, so add these together, get negative 7m. The e's cancel out, which is what we want. And then this would be negative 175, I think. Add those together. Divide by negative 7, and ooh, that's pretty cheap. That's kind of a steal. The math books are only 25 each. It's a pretty good deal. All right, and then we got to find the cost of an English book still, so plug this in. So do 5 times 25 plus 2e equals 145. So multiply those together, you get 125 plus 2e equals 145. minus 125, so 2e is 20, and then divide by 2 and you get 10. So not surprisingly, the English book's a lot cheaper because, I mean, honestly, who wants to learn English? I'm just kidding. English is important too. But anyways, in this case, English book's $10, math 25. All right, that's it. Hopefully this video helps you get ready for today's quiz. Thanks for watching.